After studying this module, you shall be able to know about the characteristic of toxicological examination, the limitations and complications of any toxicological analysis, the indications related to the general toxicological procedures. Analytical toxicology is a branch of forensic science which deals with the extraction, isolation, detection and estimation of various types of drugs and poisons or their metabolites in biological and other materials in low concentration. The unswerving evidence of poisoning is its detection in various tissues obtained at autopsy or detected in urine, blood and gastric lavage taken in living patients. The detection of a poison in various tissues is the evidence of its absorption, but this does not apply in the case of ingestion of corrosive poisons like mineral acids and alkalis, the concentration of which can be determined only on the site of application or on the gastrointestinal contents. In chemical examination, many simple errors may take place due to by unskilled usage of techniques, anticipated sanitation and use of substandard chemicals and equipments. Therefore, toxicological examination should always be undertaken by knowledgeable and well qualified experts. The examination is desirable to be carried out in well cleaned, consistent and standardized equipments, and chemicals of highest purity should be used. The common poisons encountered within India are insecticides or pesticides, poisonous plants, alcohols and sedatives. Poisoning is largely indicated by crime scene investigation, prescriptions, medications, history of the case, autopsy findings or negative findings, which means absence of any disease or sudden deaths, etc. When a particular poison is suspected, direct analysis can be done. This will either confirm the doubt or exclude the poison. If such analysis is commenced, the test applied should be specific and the poison confirmed by various techniques, and other substances which perform similarly should be excluded. In certain cases where no information about the identity of poison is available, the expert's approach will fluctuate depending on his knowledge and experience, which means if a person dies after several days of hospitalization, it would be meaningless to do the analysis for volatile toxic substances or most of the organic drugs. During the period, these substances would have to be eliminated by the body or completely metabolized. The only toxic substances which could be detected after such a long time are usually metallic poisons like arsenic or other poisons having cumulative effect, or some fat-soluble substances. When the effort of the expert fails to detect this substance by direct test, he should carry on systematically and make the use of protocol for analysis by dividing the substances into various groups and utilize the various extraction, purification and identification measures. Now, the toxicological examination of putrefied materials. Disintegrated viscera lead to several difficulties of toxicological examinations and complications in the elucidations of results. In decomposed bodies, the tissues are softened and liquefied by autolysis, and bacterial actions release carbohydrate, fats and proteins which are extracted with the extracted material in plentiful amounts and confuse the process of examination, leading to serious difficulties in the interpretation of results. Therefore, appropriate cleanup procedures should always be applied to eliminate these materials from the extracts. Some of these substances go through chemical changes along with the decomposition of tissues. Hence, such substances are not detectable by chemical tests. Example, chloral hydrate, sodium nitrite, cocaine, aconite, atropine, etc. Some substances are formed in the tissues by decomposition, which gives analogous chemical reaction to those obtained from drugs or chemicals such as neuralin, mescaline and mydelin. These reactions may mislead the expert. Volatile substances are lost as a result of decomposition, and cyanide, ethyl alcohol, ketones and sulfides may be formed from ordinary tissues component. All the same cyanide so formed is always in trace amount, but the alcohol produced by the advanced decomposition may be from 50 to 100 mg%. Regardless of the decomposition, many toxic substances are still discernible. Example, carbon monoxide, cyanide, fluoride, barbiturates, phosphates, insecticides, hyoscine, strychnine, thiovetin, serpinin, nicotine, many other drugs and metallic poisons. Now, the toxicological indication. A toxicological report should be direct in a simple non-scientific language. The expert should confirm the findings by different independent and uncorrelated factors. Whenever possible, three entirely different analytical techniques should be used, which means color test, chromatography, in this TLC, GLC or HPLC, etc., and spectroscopy, in this IR or UV. The actual choice of parameters or techniques is left to the freedom of choice of the expert in view of the poisons involved, resources available and the standard of proof acceptable in the prosecution system within which the expert work. More complex and highly sensitive techniques should be avoided in routine examination. These techniques should be used only when, for all intents and purposes required, which means when the poison is suspected to be present in a very low concentrations and other less sensitive and simpler techniques fail to detect it. The more complex methods are needed only for certain forensic requirements such as comparison of samples or the development of typology. Secondly, it turns out to be difficult to describe these techniques in the court of law in a non-technical way. The report of toxicologist generally states those substances which have been found and sometimes their concentrations. However, the toxicologist should make sure about the maintenance of a detailed record of his work, including the substances for which negative results were obtained. The record should also contain the particulars of different steps of the procedures, the methodology used, the dates of the work and the test results. For accurate interpretation of an analytical result, the expert requires the proper understanding about pharmacokinetics and metabolism of drugs and poisons and the techniques. Now, the contraindications of toxicological findings. Several times it is observed that even with the history of poisoning, poison is not detected in the exhibit material. There are a number of reasons for these actual contradictory analytical findings, such as the poison may have been vomited out, excreted, neutralized, metabolized, detoxified, or the poison is in such a small quantity that it cannot be detected by the existing methods of chemical analysis or the quantity present or extracted is lower than the detection limit. There is also a chance of the absorbed poison might have not uniformly distributed in various organs, which fluctuates with different poisons and also with its modes of administration. Example, blood levels are higher than liver levels when the poison is administered by intravenous route, and the contrary mostly applies when the poison is administered orally. Occasionally, the amount of material received may be small, but the expert has to look for all potential types of poisons. The detection of highly potent toxic, which means low lethal dose substances, is quite difficult. The interference of proteins, fats, and decomposition product often makes the detection difficult or rather impossible. The treatment given to the victim may alter the poisonous substances and make its detection difficult or even impossible. The poison also not detected if relevant tissues are taken or if the tissues are imperfectly preserved. If tissues are sent unpreserved and analysis is taken up after a long time, the poison present in the tissues might have decomposed and remains undetected. For reasons not yet known in deaths due to intravenous narcotism and anesthetics, occasionally, even when the victim is found with the needle with syringe attached, still in vein, or material is taken and sent with all precautions, no narcotic substance or anesthetic material is detected. Considering such limiting factors, non-detection of poison in postmortem tissues should not essentially be interpreted as no poison having been involved. Now, the typical features of toxicological analysis. The isolated material may be different than the suspected to be consumed. Since certain compounds are altered in the body by biochemical process, example, detection of phenobarbital when primidone has been taken and the finding of oxazepam when diazepam has been taken. Morphine can be detected from liver, urine and bile when the person has consumed diacetyl morphine, which means heroin, because the metabolic process degrades the heroin to morphine. So if the heroin is detected at needle site, it would be reasonable to say that morphine in the tissue was derived from the uses of heroin. The metabolic processes degrade a small amount of absorbed codeine, which means methyl morphine, to morphine. Therefore, detection of high concentration of codeine and low concentration of morphine suggests that the origin of morphine is probably codeine. The findings of high concentration of morphine and a small amount of codeine indicates that the morphine was due to the use of either morphine or heroin along with codeine. The presence of quinine, methaclone and any other common adulterant in bile and or urine may suggest the possibility of heroin or brown sugar addiction. But this finding should be supported by other circumstantial evidences. The reaction of the therapeutic dose of any substance may range from a slight effect to signs of overdosage. Therefore, the so-called lethal dose cannot be fixed in any mathematical use. As such, a person can survive after consuming a fatal dose, whereas a non-lethal high dose sometimes results in death. Such results are due to personal variations in response to each individual. Age, weight, sex, state of health, route of administration, and the association of other synergic substances also play vital role. The lethal dose is the dose that kills in the case in question. It may be fairly small in those who are seriously ill or who show idiosyncrasy or allergy to the poison or drug. Such a dose may hardly have any effect in those who are habituated or addicted to the particular substance. The implied term minimum lethal dose is the smallest dose that has been recorded as fatal to a healthy person of that age. It is normally about 10 times the maximum pharmaceutical dose. Now, the limitations and troubleshooting. Every single quantitative measurement has a certain degree of certainty, and the result quoted without a probable error can be misleading. While recording results, the term average should not be used without serious consideration to any individual situation. Example, such terms can only be used if all sample lose equal amount of drugs with negligible variations after preservation. But in actual practice, some samples lose more and slightly hardly lose any amount. Legally, if the term is average, if used, indicates that every sample loses the same amount. Normal values are averages of many observations. Therefore, when a substance that is normally not present in the body is isolated, it indicates exposure to the substance. But when a substance that is normally present in the body is isolated, it becomes necessary to consider a range of values before interpreting the result as exposure to the toxic levels of this substance, which means quantitative analysis is required in such cases. There are many poisons like proteinaceous poisons. Once absorbed are rather impossible to extract and detect from tissues by chemical methods of analysis. Similarly, the extraction of water-soluble compounds is very challenging. It is the responsibility of the medical officer to determine the cause of death and the time elapsed since death. The toxicologist can only state that a potentially toxic substance was taken and also estimate the quantity taken. If this is in the range of a toxic or legal dose, and if all other clinical and pathological findings fit, then it can be said that the poisoning is the cause of the death. It is often possible to give a rough estimate of the likely survival time after exposure to fatal amount of various toxic materials. Now the summary. Analytical toxicology is the branch of forensic science which deals with the extraction, isolation, detection and estimation of various types of drugs and poisons or their metabolites in biological and other materials in low concentration. In chemical examination, many simple errors may take place due to by unskilled usage of techniques, anticipated sanitation and use of substandard chemicals and equipments. Therefore, toxicological examination should always be undertaken by knowledgeable and well qualified experts. In certain cases, where no information about the identity of poison is available, the expert approach will fluctuate depending on his knowledge and experience. Techniques should be selected in the view of the poison involved, resources available, and the standard of proof acceptable in the prosecution system within which the expert work. More complex and highly sensitive techniques should be avoided in routine examination. The interference of proteins, fats and decomposition products often makes the detection difficult or rather impossible. The treatment given to the victim may alter the poisonous substances and makes it detection difficult or even impossible. For accurate interpretation of an analytical result, the expert requires the proper understanding about the pharmacokinetics and metabolism of drugs and poisons and the technique.